So, in this short video, I want to discuss the notion of game object state in Unity, that is Unity 3D. Of course, game object is the most used tool in Unity. Every time you create something in the scene, whether by using the hierarchy or via instantiate in code, you're creating a game object. I mean, there are exceptions which we'll talk about later. Now, so I mean, creating a game objects is quite easy. Of course, in Unity you work in the context of the idea in the context of scenes, and game objects normally get created within the runtime within a scene and get destroyed when the scene is unloaded and whether the game stops or another scene is loaded. But of course, one may have the need will raise to have data shared across scenes. And then there is the notion of course, of static properties. That is, as in every language that actually runs in a virtual machine, you have to distinguish class instances of which, of course, game objects via component can represent several class instances on the same game object. But what's about static properties, which are persistent across the virtual machine? And another thing you may experience is as soon as you create singletons in scenes, that is class instances of a certain type, which are meant to be unique across the virtual machine or across the scene, uh, two things may happen. That when you reload the scene, actually the singleton is not a singleton because there are several instances of it, and and uh, um, and another is that objects which are singleton and static, so you supposedly meant to survive across scenes, don't actually survive across scenes. And all this also should always consider a highly practical principle, which I invite you to follow, which is to make the game runnable from every scene. Now, if I somehow have a game object which is created in a scene and should persist to exist in another scene, then so let's call them scene 1 and scene 2. If scene 2 has to possible to run it without first running scene 1, somehow the global objects which we want to be shared across scene, they somehow be duplicated in scene 2, or which is the proper way to handle this problem? Well, I think that in order to answer all these questions, one way is to get a clear idea of the different scope and lifetime of game objects. So for this end, in order, of course, to put some order in my own ideas, and then possibly to share with you, I create a little graph which should help us go through all the possible cases. Which so there are not so many of them, and I think if you have this clear, you can answer yourself to all the questions I pointed out before. So first of all, consider that if you have static properties on your classes, whether they extend mono behavior or not, once they exist in the scene, these static properties will be preserved throughout across scenes and throughout the game life cycle, unless of course you kill them by hand. As long as those static properties are not linked to a game object instance. So if the game object is actually a static property, which is something which is uh, can be very useful to create, in fact, for example, singletons. So if those static variables may be destroyed when the scene ends, because all the game objects in the scene will be destroyed, unless the game object has been marked with don't destroy on load, which you should be very careful in using. In fact, you shouldn't use it on for game objects which are on the scene hierarchy. You should use it only on game object singletons which are created via code. Because why? Why this? So this I'm considering the second line from the top. So game objects whose instance has don't destroy load. Well, the problem with this will be that if you create a game object in the hierarchy which is characterized with don't destroy and load, it will of course be created on the first run of the scene, but if somehow during the gameplay, so this let's call this scene 1, the player goes to scene 2 and then comes back to scene 1, another instance of this object will be created, and both of them will be marked with don't destroy and load. So this will quickly lead you to a disaster. So avoid doing this. But of course, don't destroy law is very useful if you do create it for instances which you want to be across scenes, so that if you have a method for creating them with code, then it's natural that you can use it also not only in scene 1 but also in scene 2, uh, by simply before checking whether they exist already. So in this way, you're making scene 2 runnable independently of scene 1. Then another case of GameObject is a simple singleton. So a singleton with respect to the scene. So you want it to be uh, um, the unique instance in the scene, and with a simple trick you can make it very easy to access and available to all the other objects in the scene. I'll show it to you in code this way by using this static instance. Of course, this object will be destroyed when the scene unloads. Then the fourth case is the simple game object created in the scene hierarchy, which will live and die with the scene. And then there are all the game objects created in code. And of course, these last two may be instances of a prefab object. So in this sense, as the prefab will be present can be present in every scene, instances of the same prefab can be created in different scenes, but of course they will be different instances. So I think these five are five cases that if you have a clear idea and distinguish them, you won't end up into trouble with scene loading and unloading. Then I just put on the side some notes on how to preserve state in general in Unity. So a very nice technique, which of course I never understood what its purpose was until I actually had to use it in code, is the scriptable object. So I won't try to explain that, but it's substantially a class serialized in a file, but with all the strong typing and all the nice object editing tools that the IDE gives you. So I encourage you to use it through an example. Then and the script object instances can be used globally in the game. Then of course there are assets that can be loaded on the flying code from the resources folder, but be careful if you loading stuff from there. For example, images, because they won't put in the atlas, so they won't be optimized. Then, of course, you can, for preserving state, you can sync from remote services and web services, or with exchanging JSON files and realizations. Particularly, latest Unity version supports JSON for Unity objects, so that's a nice way to preserve state. And finally, there are asset bundles, through which you can bundle a whole lot of stuff built in Unity and download it only when it's necessary. So that's it. I hope this clarifies for some and make things more confused for others. Oh, bye bye.